Hello, and welcome to the third session of COMP250. In today's session, we'll be doing something which is crucial for the rest of your computer science program, not just for this assignment in COMP250, and that is object-oriented programming. Getting good at this is the key to making good, clean, short, and readable code in the modern world. So without further ado, let's get started. The idea of object-oriented programming is to write less code. But what is object-oriented programming? Well, you guys must surely remember now the classic example of an object in Java. Something like a student class, where the class serves as a blueprint to create student objects. So we know that since all students have a name and a student ID, that putting those as properties of the class makes some sense. And this is all well and good. And for all our course selecting apps and all of our emailing apps, everything is working great, because we just have these students properly modeled in our code. And instead of having to look through unlabeled data, we can say student.name and access the name of the student. It's very intuitive to the way that we read natural language. And that's kind of how our code reads as well. It makes it a lot nicer and a lot more obvious seeming, right? But here's a trick. What if we needed to include faculty in a new update to our software? Well, we could write another class for faculty, but now we have to have two different loops, one that deals with students and one that deals with faculty. And you can see how, as we add more features to our app, our complexity will increase. But really, are these two loops any different at all? No. This is where the core idea of object-oriented design that we're using today comes in. And that's the idea of inheritance. A class can have a parent class from which it inherits certain properties. The classic example of this is a class animal, which has a method makeSound. That method is then overwritten by a dog class and a cat class. Let me explain. In the definition of an animal, we know that an animal is able to make a sound. But we don't know which sound it's going to make because we don't know anything about this animal. This idea of not knowing anything about this class but knowing what's going to be there is called an abstract class, and that's going to be very crucial as well to your understanding of object-oriented programming. So abstract means we just know it's going to be there, but we don't know what it's going to be. Then, when we have a specific example like a cat or a dog, we can implement that abstract method and see its function. And it differs for both animals, right? For a cat it says, meow. And for a dog it says, woof. Right? So it makes sense. This idea will be paramount to the challenge we're setting you today. So without further ado, let's get right into it. Basis of what exactly we're doing. We're going to make the game chess, but we're not going to worry about the actual coding of it. We're going to do a higher level task. We're going to actually just design the game. And we'll see that the code is actually very short and natural if we do it smartly. But before we can design a game, we have to explain it. So bear with me while I go over the basics. Chess is a two-player game played on a two-dimensional board where each player controls its sort of army of pieces. Each piece has a dictated rule of where it can move, and that rule can become quite complicated. For example, a pawn, it can move 1 block forward, or 2 blocks forward, or 1 block diagonally, depending on the situation and the conditions. But that small detail is also not something we're going to be super concerned about. We will be providing a sort of PDF of the basic chess rules we're going to be implementing, just for your reference, but you won't be responsible for personally writing the logic for these. No. Instead, what you'll be concerned with is the idea that every piece has a different logic for how it can move. And we, to write our game, need to be able to identify which moves are valid. For example, if it was valid to simply move any piece to any square, you could instantly win by just moving first, right? The challenge of chess is that your pieces are limited to a certain range of movement. Our task for you is to write a method. Well, actually, not even write it. Our task for you is to enable a method to be written, which is under 15 lines, which takes as argument 2 cells and tells you whether or not the thing at cell A can move to cell B. Simple as that. Simple Boolean, can it move to that cell? Now that might seem kind of complicated, because you have very complicated logic for which piece can move where. And you only have 15 lines to do it. But remember, we're using object-oriented programming. So are there any object-oriented concepts that you can take advantage of that you heard about today or previously? You'll be given the opportunity to work in groups with TAs to come up with the best object-oriented design. Then, once your design is up to snuff, it should be absolutely no trouble at all to quickly plug it in to a visualizer of the game and see your work in action. So without further ado, let's get ready.